Hello, everyone, and welcome to today's webcast, Unlock the Power of Network Visibility in Industrial Environments. Our featured speaker is Dean Parsons. Dean is the CEO and principal consultant of ICS DeForce Force and brings over 20 years of technical and management experience to the table. As a SANS principal instructor, Dean teaches ICS 515, ICS Visibility Detection and Response, and is a co-author of the SANS ICS course, ICS 418, ICS Security Essentials for Leaders, and an author of the SANS ICS Engineer Technical Awareness Training. If during the webcast you have any questions for Dean, feel free to enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording will all be available for viewing in the next 48 hours, all of which can be found on the SANS registration page. And with that, I'd like to hand it over to Dean.
Excellent. Jennifer, thank you so much. And welcome everybody to today's webcast. I probably won't take the full hour, but I have a lot of content we're going to go through, and all of it is related to the SANS ICS Critical Control number 3, network visibility. So we're going to understand what it is, understand how to potentially deploy it, considerations, and the main piece here is the benefits from this control in the top 5 critical controls. So welcome to today's webcast. Just a quick introduction again, Dean Parsons. This is what I do in the field as a SANS instructor. I'm a principal SANS instructor, and between my SANS teaches and missions with SANS, I'm in the field regularly talking with engineering staff on plant floors, meeting with IT security folks, as well as taking my hard hat off and presenting to the board of directors with a tie in it sometimes as well. So my field work and experience is also going to come through in some of the content for today. So quickly, the lineup for today is we will review some recent statistics we see on the threat landscape, but of course, on the controls, we see facilities being pushed out into their environments. And they do relate to the ICS 5 critical controls. The question is, which ones are most prioritized today? They all are important, as is Control 3, today's conversation, and visibility. So we'll talk a little bit about those controls at a high level, look at some statistics, and then build a foundation to get the most benefit from ICS network visibility. There are some precursors that would give you more benefit rather than just first rolling to that control specifically. But you will see the major benefits from this one control, control number 3. Then we'll talk a little bit about some deployment considerations as well. There's 2 main ways to do this, and so we will review the pros and cons for each of those. Now, as Jennifer mentioned, Q&A time for sure at the end. If there's any questions, I will address those. So please drop those in the Q&A section in Zoom and we'll get started. So as you're here, let's get into the statistics I want to go through quickly. And there are a number of controls we can choose to deploy in a control environment, regardless of sector. And I would be remiss if we did not bring up the technologies and trends we're seeing today, most prominently being talked about in the industry, in the community, and at the board level in some cases as well. They want to understand, is this new technology viable? How do we deploy it? When should we deploy it? And that does play part and parcel to what we're talking about today. So one of those technology trends that we're actually tracking, working with, understanding how to navigate and deploy where it makes sense is AI, so artificial intelligence. And so what we do know is that there are benefits to leveraging AI in a certain, I'll say, maturity level. And what I will say is that we've been tracking information on this for quite some time. And every year we do a survey, and the most recent survey we have indicates that only 10% of respondents are currently using and leveraging some form of AI for their ICS and OT security strategies. But we are tracking this, and this number is growing. The question becomes, how can you leverage AI and when is the best time to do so? And is it the period of leveraging AI for the sake of adopting a new technology? Or how can you strategically use it to support safety and reliability of operations, in our case, in OT and ICS? So the reality is, my suggestion is there's a number of things we can do before we leverage AI. However, when it's time and it's appropriate, AI can help with preventative maintenance aspects in engineering processes as well. But at this time, we do not think it should be a technology or tool that would be making decisions on behalf of the industrial control environment. So let's take a look at a little bit more technologies as we're seeing. This one will continue to grow and grow at a pace that hopefully we can absorb to prioritize, you guessed it, safety and reliability. The next one is obviously cloud. That's been kicking around for quite some time in the ICS. IT's been doing it for decades really, really well. From our perspective, we do see an uptake in cloud services and usage for ICS as well. There are good ways to do this and bad ways to do this. 26% of respondents, based on the survey data, are right now utilizing cloud services and technologies for their industrial environment. So that could be things like, in some situations, control capabilities. It also means data historian capabilities as well. So data in the cloud processing and so on and so forth. We have seen an increase in this. So 15+% in this case over the previous year. So this continues to also come up and be adopted. Fairly low rates right now, but it will likely increase. And that's fine if it's deployed to protect safety and reliability. So the question then becomes is, okay, great, we have these new technologies. We'll talk about controls in a minute. What about the threats? What about the incidents that we see? How do the attackers get in? Is it through cloud? Is it leveraging AI? Because they do use AI as well to create attacks and profiles. And so how do we now understand, our organizations and facilities, specifically in ICS OT, prepared for incident response at an industrial level? We have some statistics on this as well, and this does change, and the most recent stats are only 56% of facilities that have, or ICS organizations have, a dedicated engineering informed, so underline that one, right? Engineering informed ICS incident response plan. So this is not your IT plan. This is something dedicated to prioritize engineering systems and even the systems, of course, that run the control environment that are not running Windows and Linux. So a lot more of those than the traditional operating systems inside ICS. So only roughly about half of organizations are prepared. Now, one of the aspects we'll talk about in a moment is, how do you prepare for this? What do you do rather than just have an ICS specific plan, exercises and so on scenarios? But why do we need this plan? Well, here's why we need this plan. Because the adversaries continue to threaten and actually get inside of control systems to cause consequences related to safety time and time again. And I'm not talking just ICS specific malware, because there's definitely that can kill people, injure people, damage hardware, etc. But also the IT malware that also seeps into the ICS environment also causes problems to safety. So if we take a look at the vectors we see, primarily from a process perspective, 46% of ICS and OT compromises comes from an IT support network that is allowing the threat into the ICS and OT environment. So that today is the top vector that we see. So that transition between one network and the other is definitely a major common pathway for adversaries in all sectors that we see across industrial environments and in all regions. So you might be thinking, if you're a defender now or an analyst or someone in the SOC, what about architecture? And you'd be right, because architecture can drastically reduce that number. There are other ones here as well. External remote connectivity, which hints at remote access, and so on and so forth, which we will talk about. Internet accessible devices, engineering workstations are targeted because, let's face it, living off the land has been a thing for like 12+ years, and living off the land does not require a vulnerability, an exploit, or any such thing. It's living off the land, meaning it's using the systems against themselves. One example is using the engineering workstation. If an adversary gets there, they can legitimately use that engineering software, allowed through firewalls, to touch, change, control, and manipulate programmable logic controllers. Another common technique we've seen. So, what about the technologies or tools, we'll call it, the controls? Well, we do know, if you're new to ICS and OT, coming from IT, you might have a great passion. Boom, let's go do ICS and OT security. And that'd be awesome. We need more people in ICS and OT cyber defense. But one word of caution, if you take and copy and paste your IT controls, processes, technology, you will kill your industrial control environment. You'll riddle it with false sense of security, false positives that directly impede safety, generally because it's not ICS protocol aware, or the techniques it uses to spot threats and thwart threats are really not up to snuff when it comes to the control environment. So be very cautious on this. Enter the 5 ICS cybersecurity critical controls. If you haven't heard of the controls, we will go through briefly in a moment on this. I'm going to focus obviously today on one, which of course is network visibility. And so we will provide also a link to the white paper for the 5 critical controls as well. So keep a note for that. in the chat as we kind of move along. So we know not to use IT controls. The 5 ICS critical controls are control system specific. So we've asked the question. So what is organizations spending their money on? How do they prioritize these specific controls? And we were not surprised with the results. And happily, we are happy with the results, glad about the results, and they are as follows. The top two ICS specific controls that are being budgeted for and deployed right now, and this is recent data, is number one, defensible architecture. You guessed it, removing or reducing that capability of the adversary, pivoting from IT to ICS, which is extremely common still. That architecture will not only reduce that threat vector, but it will also, and I love this piece, it will also align you very well for the second control, which is ICS network visibility. We're going to show you that network visibility has way more options and way more, I'll say, benefits than just a one specific control. It gives you like 5 different things. So you implement that control and it gives you automatically 5 different things. But doing architecture first makes the most sense. So then we see incident response, and then of course remote access and risk-based vulnerability management. So our focus is really going to be on visibility, but I do want to touch on all 5 briefly and then really hit on defense, strong foundation with defense, and then appropriately deploy network visibility. I want to show you how as well. Reminder, any questions so far, drop those into the Q&A section. The SANS 5 ICS critical controls are as follows. Number one is an incident response plan. As we touched on earlier, only 56% of organizations actually have one. So this is not your IT plan. It's an ICS-driven engineering informed plan with related documentation on restoration of engineering devices, spotting threats in the network, ICS protocol aware detection capabilities, and exercising that plan using tabletops or ranges or something similar. And in doing so, then you're prepared for industrial environments. But the scenario you select for the ICS incident response plan and tabletop must be also engineering driven. Otherwise, you're not actually testing the control system components. And that's the business. So we need to understand and make sure that the scenario is absolutely aligned with engineering. Number 2 is a great one to talk about as it pivots into and builds up the foundation we need for control 3, visibility. So defensible architecture right here is enabling you to not only segment between IT and the internet and protect the industrial control system from hostile environments, etc. By doing so, naturally, as you segment out your network, you actually can follow something like Purdue and bake in security on top of it. You can actually use this to pivot out and have different sub networks in your control system environment using industrial grade firewalls that allows you to also not only segment, but give you packet captures as part of the visibility piece we're going to hint at. So our purpose today is only going to focus primarily on this one, which is ICS network visibility. I'll come back to this in a second. Secure remote access is the 4th control that is extremely valuable because of the threats we're seeing, followed up with risk-based vulnerability management as the 5th of the 5 ICS critical controls. Now, of course, risk-based vulnerability management is not just, oh, we have a high score on the CVSS, so we need to patch that vulnerability. There's a lot more context required inside of a control system because it's a different risk surface and access points into ICS than the IT environment. So it's a different context you need for ICS patch management and vulnerability management. But back to network visibility, and as we go deep into this particular control for the remaining time that we have today. Now, I teach ICS 515, and a lot of it is directly related to this control, network visibility, packet captures, threat management, and threat understanding, threat detection, of understanding lateral movement, extracting network information for forensics analysis, extracting files that are laterally moved as well, understanding what is normal in the network and what is abnormal from an engineering perspective. That means visibility must have in the ICS capable or aware dissectors. It must understand those protocols we know and love that run our world, that makes and moves and powers our world. Modbus TCP, Ethernet IP and SIP, S7, for example, and so many others. So there is a process we've actually deployed. It's kind of a best practice now over the number of years, and it is directly related to visibility. And the process we push out that is a daily, repeatable process is active cyber defense for control system environments. It is this five-step process. So ingest threat intelligence and apply that to, you guessed it, visibility on the network. Threat detection comes after, industrial grade incident response with your ICS specific plan, and changing your environment or the threat itself with threat and environment manipulation. So this is the repeatable process. So you'll see here that visibility is highlighted, and the reason it is highlighted is because without visibility, this entire cycle will fail. So the idea is to make sure we build a strong foundation first. That's going to be architecture. Then, of course, we need to go into visibility. So one of the five controls we talked about was architecture. So if you look at this example of an architecture, you will quickly determine this is a pretty basic and pretty, we'll call it a flat network, a flat architecture. Not ideal, not what you want at all, for a number of reasons. So for example, if there is a contaminant here at this level here, perhaps the engineer workstation is compromised, then there's nothing really to stop that from getting access to an HMI or laterally moving to another part of the engineering process. So at the very least, the idea is to have some foundational segmentation. So moving from this to something like this is a little better. You have at least some segmentation between process A and process B. Now, this is also not super ideal because only one segment separating A and B, while it's not a super loss, but it's pretty good. But there's still additional ways to achieve, I'll say, segmentation, especially at lower levels in the Purdue. So there's another thing here I want to bring up because not only do we want segmentation for the obvious purposes of containment during incident response, but as you naturally progress towards a good architecture, segmentation, when you're doing that, those segmentation points like this firewall we see here and fully managed switches or taps in the network allows you to create choke points to get packet captures. That's the visibility that we need. So in this diagram, we're going to come back to this and talk a little bit more about, well, where do we want to get the network traffic from? You might ask the question, where's the best opportunity to get that traffic? Is it at the firewall we see in the middle? Is it below that, down closer into the control system environments? And should we deploy something called a tap, or should we rely on a fully managed switch that has a span or mirror port configuration? These are some of the options that we'll go into as we pivot through. But first I want to talk about, okay, check. We got the foundation. We have a strong architecture in place. Then what are the benefits of now deploying at this point the network visibility? So I want to really go deep into the main things that visibility provides. It doesn't just give you packet captures. What you do with that packet captures and those files and the information and the flow data and the baselining of that network information from an industrial perspective, what you do with that gives you five major benefits. So let me rephrase this. This one control gives you five things that you need for industrial control environments. So let's take a look at all of these five real quick, and then we're going to talk about where in the network should you deploy this. What are the considerations we must go through? What's the risk with deploying such a type of control or a technology? Another reminder, any questions, drop those in and we'll talk to you shortly. So the first thing I want to get into is that because network visibility should deeply look at the packet captures on the network. So not just your IP fix or five tuple data, really looking at the deep packet analysis, the payload of the traffic and the function codes inside the packet payload. That will give you threat detection. That's number one. Threat detection capabilities. It allows you to see lateral movement. It allows you to see abnormalities. At a deep packet level, it allows you to see if you're running Modbus TCP, it shows you the function codes that you would normally see. And it shows you the ones that are abnormal or the ones you normally see, but you shouldn't see them at that particular time in the network, or devices communicating that they shouldn't be sure during a period of time. So it not only does threat detection on anomalous activities, it can spot ICS specific targeted attacks, as well as IT related malware that seeps in, as we talked about before, 46% of the time, an ICS is compromised. In addition to that, because it spots anomalous activities such as communications from an engineering workstation to a programmable logic controller to upload new logic to change it, possibly manipulate it, that living off the land capability, that does not require a vulnerability, does not require an exploit, meaning the adversary doesn't have to bring that tool set in to the environment, which means this living off the land capability is also abusing the control system, which network visibility does also give you indication of as well. But the idea is to spot this before it happens. So earlier on in threat detection, we're looking for lateral movement between commonly targeted devices. And from networks we know the threats are coming in from generally. In addition, number two, because it's not only threat detection, we should have copies of the packet captures, meaning any file transfers in and out capabilities are actually capable now to pull out of the network, meaning you can do quick triage on this, forensics analysis on files going around the ICS. And when you have copies of files, you can do quick analysis, static analysis as an example, sandbox analysis outside in a safe environment to quickly triage and understand the threat you're dealing with inside the control system. Not only does it do that, it provides you safe vulnerability management, meaning when the communications are happening on the control environment, you're spotting that, you're seeing that, the protocols, the devices that are communicating, not just the IP addresses, but how they're communicating, how often they're communicating, the devices themselves, the model numbers, the make, the firmware versions, all of those things are going to be seen passively and safely in the environment. There are other ways to achieve vulnerability management inside of a control system. I would wager that they're still way, I'd say, yeah, more risky than this passive assessment view. Active scanning is something that can introduce risk, but gives you quick information. But suffice it to say that safe vulnerability management here gives you a ton of information about the vulnerabilities of the assets you're running. And then you can tie that back into threat detection from active cyber defense cycle that we covered a few moments ago. It's important to note here, though, that with security, I'll say safe vulnerability management, CVSS scores will be part of it. But remember earlier we talked about the asset context. Where is the device? What is the likelihood and probability that that device could be accessed and that vulnerability could be exploited and so on and so forth. So it's really a combination of, okay, great, we have this CVSS scoring, that's wonderful, but what's the probability of the adversary getting access, finding the vulnerability, exploiting it, and then following up with, I'll say, consequence-driven actions that the adversary can't do just by using the control system against itself. So there's definitely context required there. Number four is because we know the assets that are communicating, we now can build an asset inventory, OT asset inventory. So your targeted devices and control systems, PLCs, HMIs, historians, protection control relays, all of those devices will be seen if you're looking in the right place, but you can now detect information about the models, the firmware version, as we mentioned before, not from a vulnerability perspective, but an asset inventory perspective. That can be married up with number three and threat intelligence from before. Last but not least, the benefits from network visibility. Everything we've covered so far, I hope you'd agree, is all security related. Maybe inventory is also engineering related as well, but definitely from a security perspective. Number five is one of the most impactful things that this tool or this control provides because it's not just security, it is engineering. It does troubleshooting or has capabilities for troubleshooting engineering specific communications. It has the content anyway. It knows the protocols. It should know the protocols. It knows the protocols, so it knows the packet captures and the function codes from all of the common ICS industrial environment protocols. Meaning, if there is something newly deployed or that has already been deployed and there's a state change, then that change can be seen on the network. And of course, engineering troubleshooting and root cause analysis can happen with engineers looking at that from their perspective to see if things are functioning right or not, or as optimally as not or not. So not just a security mindset here. It definitely helps engineering. And a very quick story is, and I've seen this many times, I've experienced it many times, and we've deployed many times like this in the field. I've actually seen organizations deploy this, and within the first month, they really spot a lot of engineering troubleshooting items, meaning they go to the engineers and say, this is not malicious, but maybe it can help you. And the engineers are like lighting up because it's, you're proving the point that there are systems that are misconfigured, and that's what's causing issues or slowdown. So tons of value in number five here from an engineering perspective. So it's not just security here. All of this supports safety directly. It's number five as well. So, all right. So When it comes to where do you deploy this to obtain all of the benefits we see on screen, you'll be left with an option, two really, and maybe you want to do both of these, and that would be the ideal state. But the question will become, which one do you do first? Do you only do one? And I'm referring to when you deploy network visibility tools and monitoring, you're going to be faced with, do you do north-south versus east-west traffic capture? And that directly refers to where in an organization or facility you're going to capture that information. So as you see on screen, we now have a reference to a basic layout of a network. Just to understand, we're not focusing so much as on segmentation here, but more so on where overall, inside or external at the perimeter. So north-south in this case. North-south is your upper firewall. You can call this kind of maybe even your ICS DMZ. It's the external kind of point of presence for your ICS network. Now, there is value, of course, in capturing traffic at that firewall or set of firewalls. You will see things that are crossing the boundary in and out of ICS into OT, remote access, which is helpful. Remember, 46% of the time compromises are in ICS from IT. So you can spot those kinds of things there at that level, the north-south firewall. But then the question becomes, what about east-west? What can we obtain down there? Is it security related? Is it all security related? Or is it engineering focused? Where's the benefits align? So if you just recall, we covered five main benefits. The question now is, where do we get the most of those benefits? And then it's, well, do we do both, north, south, east, west? And then the question is, if you could only pick one, which one has the highest benefit for your organization to maintain safety and reliability? So let's walk down through east, west versus north, south, and a use case for each of these. So if we first take a look at this one, which is north-south, the upper firewall protecting your industrial environment from the internet, from IT, etc. If you capture traffic there, because you have basic segmentation at this point. So if you capture traffic right there, your packet captures are now coming out of that firewall, full packet payloads. Hopefully that firewall is ICS protocol aware, has full protocols, and you can dissect that either in the tool or in another offline tool. If you only get north-south, this is the benefit. You can actually do analysis. It's an easy starting point, super easy to start here, but it does lack ICS context. It lacks insights. It doesn't have the protocols that are running inside the control system generally. So the idea is that you do have some use cases here, such as you can identify potential C2 activity, beaconing out from operations possibly to the internet, possibly to IT, malicious domain activity, etc., etc. And yes, you should limit or not have or significantly restrict any outbound access from the ICS network, and also any inbound as well. But that's beaconing only at that edge in this case. Another use case is cross-site traffic, meaning you're still kind of inside your or at the boundary of your SCADA environment or your ICS network. Say you have 50 substations at this firewall, maybe you have access to communications and channels of data coming to and from those 40 or 50 substations. So cross-site traffic, and that's all wonderful. There's information you can get there. There's basic information on, we'll call it threat detection capabilities, but really there is a lack of ICS context. So easy to start there, but really does lack the benefit to the control system. If you move towards east-west, you know where this is going. Traffic analysis east-west, that's internal to the control system, meaning you're now capturing, hopefully, the communications to and from critical and targeted ICS assets, your OT, Windows HMI, your main HMI devices, your engineering workstations, as an example, information going to and from your data historian. All of those components are, I mean, we've seen this continuously. All of those devices and more are targeted from an ICS TAC perspective. So east-west gives you the communication paths to and from them. Here's an example. Because we can now get information inside the ICS, specifically, we're looking at communications now of the control system protocols. We can now detect things even like living off the land. An adversary possibly is here, like we've seen with Trisis and so many other types of attacks in ICS. Here at this level, the engineering workstation is used to program the PLC. And down lower in the control system environment, and down where the PLCs are down here, for example, or even over here, that device here will communicate through the network using a protocol, which is an ICS protocol, to a controller. That is now captured using east-west visibility and monitoring. So many benefits here. Not only are you able to identify the assets now, so asset inventorying and identification in this case, you're also doing additional things like following and understanding lateral movements to the systems. And down at that level, you can detect vulnerabilities of those devices because they are giving you information on the network about the modules that they are in the PLCs, as an example, the make and the model, and so on and so forth. So you can and absolutely should do both north-south and east-west. If you start at north-south, fantastic. If you start at east-west, fantastic. Internally, if you start at east-west, you will likely see way more return of investment much, much quicker. My only suggestion is this. I have seen organizations that do take on a budget, take on the resources. Let's do network visibility. It's awesome. It's actually one of the top controls people are deploying in facilities. So when they do this, though, in some organizations, I see them lose steam quickly, meaning they start here. It's easy to start north-south, and then they stop. They do not do east-west, which means you don't get those benefits we talked about. Of the 5 benefits, they probably get one. That's it. East-west is where it's at, but you do want both. So do what works for you. If you want me to suggest which one would to do first, I can. Any questions on this, let me know. I can also share with you what I see in the field. Let me know if you have any questions as we go. So now we've covered the types of 5 critical controls. We know that architecture is pivotal to make this more valuable as a control, which is control 3 visibility. We know as well that we have options of north, south, and east, west areas to grab the packet captures we need for all of the 5 benefits with this control. So then it becomes about the considerations of what type of infrastructure do you deploy and when do you deploy it? So what options do we have? So there is some visibility considerations here. Now I want to share with you 2 main ways to achieve this type of control. And I don't want you to walk away from this webcast thinking this is a major uplift. It does not have to be. And in fact, if you have 50 sites, cool, do one site at a time, phase it in, learn as you go as well with the engineering staff. Because to deploy this control, you will have to work with engineering staff, which is awesome because they know the control systems and the ICS protocols, etc. They know the architecture, and that is going to be pivotal for these considerations. So number one is you can choose to use a fully managed switch or a mirror port. Now, interestingly enough, in legacy environments, we do see older switches that may not be fully managed. However, in fairly new and modern times, we'll say even 10 years, you will see fully managed switches capable and already deployed. So the key piece here is it's likely already deployed in many control system environments, these fully managed switches. Watch out for legacy environments. This does not require outages to configure to obtain traffic analysis, meaning it's already in the network, likely in your facility already. It's a matter of configuring it properly with the engineering staff and then pushing the packets to a device or getting them right from that switch. So usually connecting up, and this is how I do a lot of my assessments, connecting up to those managed switches, enabling the port or mirror port, which means it's taking all the traffic from the network that it sees going through the switch and pushes it and copies it to one port. You then siphon that off to your tools offline to do analysis. That is one way to do it. Usually in a larger scale situation, that span configuration is pushed all the data into a larger sensor and so on and so forth. So the idea here is no outage required. And you can phase this in over time if you properly do your network segmentation. So while we know VLANs are not security related, they can be used to segment out and route traffic, which means on a switch using VLANs, you can add to your span configuration 1 or 2 VLANs at a time. This reduces the risk of possibly dropping packets from a fully managed switch that might be undersized and overloaded. So it allows you to reduce this risk. It's already deployed in your environment. Yes, use change control and work with your engineers. This is one main option. If you're curious, let me know in the comments or the questions if you want me to share with you which one I see the most often when I'm deployed doing assessments and doing incident response. Is it a switch, fully managed span, or is it a tap? And a tap in this case here, as you see on the right and the bottom, This is inline in the environment, an inline purpose-built piece of hardware. And in this case, you have to take an outage to install it. So it does require downtime in the control system to usually enable and push in a piece of hardware. Once you do that, now you're connecting up all the normal communications through that hardware. Yes, it could be a single point of failure. Yes, it's supposed to fail in a way that allows traffic through it. I've seen them fail multiple times. There are pros and cons to each of these methods. So in this case, requires an outage, but it's purpose built. It's for this exact reason to copy the traffic, and it installs inline. So there are pros and cons to each of them. Whichever one you select to go forward with, whether it's a fully managed switch already in your network as it is, no outage required, or a purpose-built piece of hardware which can get expensive, either one you do and go with, the best option is as early as you can in any new projects is to get ahead of these kinds of things, meaning in deploy your infrastructure at a time that it is optimal, as in the design phase of any new project, that's where you want to be to start. Meaning, in the design phase, when you have a new system going in that requires a fully managed switch, or you can put a tap in any network changes, that's the optimal time to get part of this process. Meaning, you have to have some kind of network capabilities to get those traffic packet captures. So, connecting with your vendors, connecting with your engineering staff to enable this as a requirement is really the best way to go, because then it's pushed into production and there's no requirement later on after the fact for reconfiguration or deployment and cutting off network capabilities and downtime. You have the design phase, that's your early requirement information. Then there's the FAT and then SAT, FAT being the factory acceptance testing. So where your configuration matches your design, is deployed on a factory site before it's shipped to you and plugged in and actually pushed into production in the factor or the site acceptance testing, integration of different devices, load testing, final commissioning, and so on. So these are the options you have, span, tap, and these are the three main areas you can get ahead of these kinds of things to make sure your infrastructure is set up properly early on for either a span or tap or both, whatever you decide. So we've covered a lot of content in the last little bit, all related to the five controls, visibility being one major one here with five benefits from it, making sure that we have a good architecture first that it actually enables visibility. So the main takeaways are as follows. Of the five ICS critical controls, the first one that is really being deployed the most, and like I'll say that needs to be deployed is architecture, defensible architecture. It doesn't mean that incident response is less important. It needs to happen. Incidents continue to happen, but defensible architecture informs and supports network visibility. So we've just covered network visibility. The good news as well, beyond the five benefits we just talked about with this control, once you have this in place, guess what? When you're doing remote access, now you can understand and monitor remote access. And it gives you information, as we talked about, that informs network visibility and or network risk-based vulnerability management. So tons of value here. And just one more time, the benefits of visibility is threat detection, ICS specific malware or IT malware, and living off the land attacks. Industrial grade incident response, giving you packet captures, file extraction capabilities for quick triage and ICS forensics analysis. Safe, we'll call it passive vulnerability management, discovery of critical assets, and also it informs your asset inventory to build out the inventory of what is on your network. Beyond that, one that I love, it gives you root cause analysis. Engineering troubleshooting capabilities must be ICS protocol aware. Okay, so a lot of information. I knew I wasn't going to take your full hour. I wanted to make sure I respected everyone's time on this, but the main takeaways we've just covered, and I teach a lot of this in this class, ICS 515, no surprise, ICS visibility, threat detection, and industrial grade incident response. In this class, this is the PLC every student gets. Yes, you build it in class. We hack it, defend it, all class. You get to keep it, so you take it home for further development. In class as well, we map out the network using the idea of a span or the idea of a fully managed switch. We understand a little bit more about how to deploy those and the specific areas in the network of when and where to deploy them, all the way deconstructing ICS targeted attacks, advanced persistent threats, events that we've seen, but also preparing your incident response plan, all informed from an ICS and threat intelligence engineering driven perspective. So if you want to join me in class sometime, check out the link here. Otherwise, I definitely want to say thank you for your time today. And I'll take a look to see if there's any questions in the Q&A section. But also, if you want to connect, you can hit me up here on LinkedIn. I do a lot of content development for the community, providing a lot of cheat sheets, posters, and so on and so forth. So please reach out if you have any questions on anything SANS, ICS, and OT, and I'll do my best to respond to you quickly. So I'm not sure if you're still out there, Jennifer. If you are, let's see if we have any questions for today. And if not, that's cool. But Jennifer, over to you for any questions that we might have.
Thank you so much, Dean. I'm not seeing any questions on my end, so we'll
Okay.
go ahead and wrap this up. So first off, I want to just say thank you, Dean, for your presentation and helping to bring content like this to the community, to our audience. Thank you so much for joining us. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. You can find your CPEs for all completed webcasts by logging into your SANS portal account, navigating to your account dashboard, then clicking My Webcast. You can then download your CPE on the right-hand side of the page. So until next time, take care. Thank you, everyone.
Thank you.